the number of elements in this set Z, Z is set of all complex numbers of this form A plus iota V, where A and B are integers, and uh, the modulus of this complex number Z minus 3 plus 2 iota, this is between 1 and 4. Now we know that this inequality, this will represent a region between two circles, one of radius 1 unit, another one of radius 4 unit, and the center of the circle will be at point 3 minus 2. So basically we have to find that how many points are there with integral coordinates. Z is a plus iota b, and a and b, these two are integers. So basically we need to figure out the number of points whose x coordinate as well as y coordinate is an integer, and the points lies between these two concentric circle. Now one simple trick and you can save significant amount of time in calculation. Here, instead of plotting this circle with center at point 3 minus 2, we are going to shift the origin. That means we are going to use shifting of origin, and will make the center of the circle at origin. Right now, for these two circles, the center is at point 3 minus 2. So instead of 3 minus 2, we'll make the center of the two circle at origin, or let us say we'll take this complex number as some other complex number omega. So then it becomes mod omega, the inequality becomes mod omega greater than 1 and less than 4. And now this will represent all the points inside a circle with center at origin and radius, two concentric circle, one with radius 1, other one 4 unit. And because we are shifting the origin by integral coordinates, right? Earlier the center is at 3 minus 2. Now we are making the center at origin. So basically we are shifting center from 3 minus 2 to 0, 0. So both x and y coordinate we are shifting by integral coordinates. So therefore number of points with integral coordinate in this set will not change. So now let us plot these two circles and then try to identify that how many points are there with integral coordinate inside these two circles. So one circle, center at origin and radius 1 unit. So that will be a smaller circle. Let us say this is the first one. And the other one will be a circle with center at same point origin, but the radius is 4 units. So this will be a slightly bigger circle. So let us say this is the second circle. This one is the real part of real axis or the x-axis, and this one is imaginary axis. Now, for the bigger circle, the radius is 4 unit. For a smaller one, the radius is 1 unit. Now, between first we'll count all the points which are inside the bigger circle with integral coordinate, and then we'll remove those points which are not inside the smaller circle, right? This inequality will represent regions between these two circles, outside the inner circle and inside the outer circle. Now let us draw different lines. This is y equals to 1 line, the next line y equals to 2 line, and another one y equals to 3 line. Y equals to 4 line will be just touching the circle at this point. So there will not be any points with integral coordinate here. And on negative side also, number of points on these, because the figure is symmetric about x. So number of points on y equals to 1 and minus 1 will be same. Number of points with integral coordinate on 2 and minus 2, these two will be same. And similarly, number of points with integral coordinate on the line y equals to 3 and minus 3, these two will be same. This line is y equals to 1 line. This one is y equals to 1. Here we have y equals to 2 and so on. Now, on this line x-axis, the coordinate of this point will be 4, 0 because the radius of bigger circle is 4. This point will be minus 4, 0. So if I talk about this line y equals to 0 or the x-axis, starting from minus 3, 0, minus 2, 0, minus 1, 0, 0, 0, and in this manner up to 3, 0, right? So on this line, starting from minus 3 up to plus 3, total will have 7 points, right? So number of points on this line, here if I write the answer here or count the number of points with integral coordinates. So on y equals to 0 line, we are going to get 7 points. When this point is 4, 0, so just before that one, you'll have 3, 0. Remember, we need points only inside the circle, not on the circle because there is no equality here. So from minus 3, 0 to plus 3, 0, total there will be 7 points. We are not, at a later stage, we'll remove the points which are inside the smaller circle. First, let us count all the points which are inside the bigger circle. So on y equals to 0 line, we have 7 points. Then on y equals to 1 line, remember this outer circle will be x square plus y square, and this equals to 4 square 16. So if y coordinate is 1, the x coordinate will be root 15. So for this point, the coordinate will be root 15 and 1. And similarly on negative side also minus root 15 and 1. Now again, root 15 is a number bigger than 3. So that means 3, 1 will be inside the circle. Minus 3, 1, this is also inside the circle. So minus 3 up to plus 3, including this point 0, 1, total you have 7 points. And same number of points on y equals to minus 1 line. So that means twice of 7 points on y equals to 1 line, another 7 point on y equals to minus 1 line, because the graph is the curves are symmetric about x-axis. Next possibility, if I take y as 2, then x square will become 12, x will be root 12. So x coordinate root 12, y coordinate 12. Now again root 12 is bigger than 3, right? Root 9 will be 3, so root 12 is more than 3. That means point 32 is inside the circle. And similarly minus 32, that is also inside the circle. So from minus 3 up to plus 3, you'll get another 7 points on this line y equals to 2. And finally this line and on y equals to minus 2 also will have same number of points. On y equals to minus 2, we'll get another 7. So therefore, I have taken 2 outside here. Now, next possibility, if I take y as 3, if y is 3, x will become root 7. Now, root 7 is smaller than 3 and bigger than 2, right? So the point 2, 3 will be inside the circle. Point 1, 3 is inside the circle. And so 2, 3 and minus 2, 3, right? This point will be minus 2, 3, minus 1, 3, and so on. So from minus 2 up to plus 2, right? Again, I'll repeat, root 7 is less than 3 and more than 2. So the point just inside the circle will be 2, 3. And on negative side, minus 2, 3. So from minus 2 up to plus 2, you'll have 5 points. 5 points on line y equals to 3, another 5 on y equals to minus 3. So these are the number of points with integral coordinates inside the bigger circle. Now we need to remove those points which are not satisfying this condition that modulus is greater than 1. That means the points which are either inside the smaller circle or on the smaller circle. So clearly you can see that there will be 5 such points, right? Those points will be, one will be the origin, and you have other 4 points 1, 0, 0, 1, minus 1, 0, 0, minus 1. So there are 5 points which are either inside the smaller circle or on the smaller circle, and total we have these many points inside the bigger circle. So the number of points with integral coordinate outside the smaller circle and inside the bigger circle, that will be this number. Now 7, this you can calculate, 7 into 4, so that will be 28 plus 7, 35, plus another 10, 45, minus 5, so that will be 40. So that should be the correct answer for this problem. The right answer for this problem will be 10. And in this question, the important concept was that once you shift the origin by integral number of coordinates, right, instead of minus 3 minus 2, we are making the center of the circle at origin. And that means in place of this complex number, we are writing another complex number omega. So the number of points with integral coordinate will not change, right? And first count, whenever we need number of points with integral coordinate either inside a circle or ellipse, then you just draw a number of parallel lines and count how many lines, how many points are there on y equals to 1 line, 2 line, and so on. So finally we got 45 points inside the bigger circle. 5 points were either on the smaller circle or inside that circle. So our final answer will be 45 minus 5, which is 40, and that should be the correct answer for this problem.